Here I will talk about our next topic, functions. Functions are really useful structures that we can build into our own code, and that applies whether or not the functions are pre-built or written by someone else and we're accessing them, or if they're new and we're defining them within our script itself. We'll first talk about data types. These are kind of good examples of built-in functions, ones that are pre-written that we can draw upon. And another good example of this would be the print function we've seen throughout this course. Then we'll get into how to define new functions in our code to help it work, to work better, I guess. I mean, really the point of functions is to better organize our code so that it can be executed multiple times without kind of retyping certain statements, and that it can be read and understood by us and by other people better. Functions are a good opportunity to talk about execution flow and conditional execution. These terms have to do with the order in which statements are executed in a code and whether or not they're executed at all. And that would be the kind of the conditional execution. So we'll see one example of that. That'll really be the next or one of the next big topics we'll get into. So what is a function? I've talked about kind of the function of functions. What purpose do they serve? But what's the textbook definition? Or I don't know, what's the slideshow definition? So a function is a named sequence of statements that'll perform a computation. So you can have a sequence of statements in your script that get executed kind of one by one. Well, a function kind of packages that up nicely and neatly. So when we define a function, we'll choose a function name and list out any parameters. These are different values that will be input into the function. Then we'll write a sequence of statements that'll be executed. Once it's properly defined, we can then call the function. That means kind of triggering it to happen. This kind of the usefulness of functions is well illustrated by the built-in functions that come with Python. And we saw one of these called type. And if you call the type function, passing a value, the output will be the data type of that value. So the function name is type. Following functions, we always have parentheses, with the exception of the print function in Python 2. That's kind of just, I don't know, it's like a fun fact, the exception, that actually they change in Python 3 to have it take parentheses. Within the parentheses is a specific argument, here 3.14, and then the output is the data type. So if we do quote 32 quote, the type is string. If we have kind of a file path directory location within quotes, the type is string. Some other built-in functions having to do with data type allow you to convert the type of a value. So here, the function int, when we pass a string as the argument, outputs an integer type value, now the number 32. If you try to call the int integer conversion function, passing a string of letters, you will get an error. It only can function, or it can only be executed when you pass a string of numeric characters, or if you pass a float number. And when you force the conversion of a float to an integer, the decimals will be truncated. So I might have said this is rounding down. That's true of any positive floating point number. For negative floating point numbers, truncating the decimals actually increases or moves the output value will be closer to 0. So a negative 2.3 becomes a negative 2. Truncating just means you remove all the decimals. If you input 32, that integer, to the built-in type conversion function called float, you get 32.0. And if you use the str type conversion using an integer, 32, you get the string 3, 2. So I say that because it's not the number 32, it's the character 3 followed by the character 2. Likewise, you can force conversion of a float to a string. Type coercion here. This is an example that's it's more relevant to Python 2, where decimals get truncated and the output of an operation like division using two integers will have the output decimal point truncated. Python 2, it's not just kind of the old obsolete version, although it is older and eventually likely will be phased out, but a lot of other applications run on it, including ArcGIS for desktop, so it is important to learn this. One example we saw earlier having to do with a minute variable equal to the value of 59, dividing that by 60, giving the unexpected output of 0. So one way to get around that in Python 2 is by introducing a floating point 60.0 as the denominator. Another way would be to call the float function to convert the value of minute to 59.0 prior to dividing by 60. I'll take a look here. I'll open up an idle session for Python 2.7, and we'll go through that example. So minute equals 59, minute divided by 60, and it's going to give us the output of 0. So if we try float minute divided by 60, that gives us the accurate floating point output. And we got to be careful though about how we close the parentheses. So we want the parentheses to close right after that minute variable. But if we forget and put the parentheses at the end, we get a semantic error. So it still runs because that's a valid input. But what happens is the division occurs before the conversion to float. So we're essentially getting this same output of 0 and then converted to a float. So it goes from the integer 0 to the float 0.0. So you got to be careful about where your parentheses end. Math functions are some other built-in functions that you may well want to access. They're not going to be accessible to you in the basic Python session though. You'll need to import the math module. So a lot of pre-written code, including built-in functions, are packaged as modules, which because of computation time, aren't loaded automatically when you open a new session, but can be imported. So one of these functions is a square root, sqrt. Let's see, I'll go back. sqrt2 gives me an error. Import math. Square root 2. Still gave me an error. I have to do the dot notation. So I'll write out the name of the module I imported, a dot, and then you might see the auto-populating function. So square root 2. There we go. 1.414 and so on. Now on this, within the box on the slide, there's the alternative import line, import math as some variable name. Here it's M. Then, if you import a module as a variable, instead of typing out math.square root, you can type that variable name. With a module called math, you're not really saving so much keystrokes or space. You're going from 4 characters to 1, but say the module has maybe 9 or 10 characters in the name. Then it might make sense to import it as a shorter variable, maybe 1 letter, maybe 2 or 3 or something, just to make your code more easily understood by a person. The interpreter will execute the code just as well, no matter what you do. So once you've imported the math module, you're also able to access some constants. So math.py, math.e, and functions such as log. You can recognize the constants because they don't have parentheses after them. Functions will be followed by parentheses. Some of these, we do have the option in the regular Python session to perform an exponential operation, but there's the math.POW for POW, math floor, which gives you the truncated 2.9 becoming 2.0, or math.ceil, raising to the nearest integer, although the type here is still float. So those are kind of built-in functions. Some that you can access in any new Python session, some that you can only access after importing the relevant module. But it's all kind of pre-written, built-in, to some extent, functions. It's often, as I say, helpful to organize your own code into functions that you define within a script. And there are different ways using syntax, or kind of think of this as the grammar of Python, to do that. So the first is the line on which you define the function. You type out DEF, short for defining, and then a space. So that little DEF is called a token, the def token. Put a space, then the function name, followed by parentheses. And if you have or if you have any parameters, could be 1, could be more than 1, parameters are values that are going to be acted on in the statements within the function. If you have any of these parameters, write out their name within the parentheses. And then a colon and a return, a new line. And on that new line, 1 tab indented, you start to write those statements that are organized within your function. So one example here, you might want to put a comment on the line above describing what the function does. Then on the line we have def print underscore info with no parameters. So it's just open parentheses, close. There's nothing inside, but you still need them there. And a colon. And then what's the statement? Print this string. Python version is 2.7. I added those parentheses, so I should probably change Python version number 2. Then, after you define, after you define the function, you need to actually call it in the script in order to have anything happen. So this is the function definition, which is read by the interpreter, but nothing actually happens until you call the function. And this is not indented on a subsequent line. You write the name of the function, and if there are any parameters, you would enter specific values. These are called arguments, representing what each of those variables should be. we'll see some examples on subsequent slides that'll more clearly illustrate that. So here's one example. In our code, we can import the math module. Then we define a function called calc_area. It's going to have one parameter called r for radius. So then on the subsequent line, one indent in, a variable called area equals math.py times r, so that's the same r as the parameter here, to the power of 2. Then something gets printed, so a little bit of a string, given r equals the string conversion of r. It's going to be anticipated here that r is a number, integer or float, but it gets converted to a string here so that it can be printed out. Given r equals whatever r is, area is whatever area is. So then, within the same script, I'll align that better, there are two function calls. So it's the same function that's being called, but it's being called with different arguments. So here 1.0 is the argument, and that value of 1.0 is going to be used in the calculation of area and in the print statement. And then in the second function call, 2.0 is the argument. That's the specific value that's going to be used for this r parameter. Think of it as just replacing r equals 1.0, r equals 2.0. It's basically a built-in assignment statement. So this 1.0 is going to be assigned to the variable r, and then these statements are executed. When this is called, the value 2.0 is going to be assigned to the value r, and then it's going to be used when these two statements are executed. So when we have defining functions and calling functions in the same script, the execution flow works a little bit different from that kind of top to bottom, line by line sequence that we kind of learn about initially. So think of it as here we have a function called workday hours, where Monday, Friday hours are printed. A different function called weekend hours, where weekend hours are printed. No parameters for either one of these. And then a function called hours, which calls each one of those previously defined functions in it. And then finally, outside of a function definition, the first and only function call in this code is the function hours. So the interpreter sees that three functions are defined, but the first statement that's executed is this call here, hours. So once that function is called, the interpreter looks back to where it's defined, and it says, okay, this function hours calls workday hours and then calls weekend hours. So what is that? When it sees workday hours, it jumps back up to where that function's defined, and it prints out this string, mon_fry:9-9. And then goes to the second statement within the hours function, sees weekend hours, where that's defined, and will execute the only statement there to print out weekends, 11 to 5. Here's a slide, slide 13, that tries to emphasize the difference between parameters and arguments. So parameters are really variables that are going to be used in the execution of statements within a function. Arguments are going to be the specific values that are passed, that are used in the function when it's called. So in this example of the parrot function, where you input a string and it prints it back to you, like a parrot might repeat your sentence or whatever you say to it, Val is going to be the parameter, kind of variable name used in the code. But what gets repeated? The specific string that's passed as an argument. These examples show that an expression here, so here a string plus another string, converted square root value, can be passed as an argument. So you don't have to simplify everything. If you have an expression that can be evaluated to a single value, that's fine. Also, this POW is a function. So you can, when calling the parrot function, also call the POW function in order to give you the argument, the thing to be printed, the thing to be repeated in this case. So what happens here is the execution is first of the POW function in order to yield or to return a specific argument that can be used to call the parrot function. And I just said the word return. Unlike the parrot function, which just prints something to the console, sometimes you want a function to return a value, to kind of have something that comes out of it. Not just that something that happens, but something that comes out of it and can be used elsewhere in the code. And for this, we want to use the return statement. So here's a little sequence called perimeter, import math, define the perimeter function of a circle. So it takes one parameter for perimeter, the radius. And what gets returned? 2 times math pi dot radius. And now, unlike kind of the previous examples, we've seen a lot of print functions. If you have return, nothing's going to show up in the shell automatically. What you'd have to do is when you call the function, you'd write print perimeter and then put a specific argument. So if you wanted something to print, you'd have to put that in the same line as the function call. Another function you might want to define would be an absolute value function. So that takes as an input x, going to be some number. And here is our example of conditional execution. So just like when we define a function, the statements are going to be one line below and indented. For conditional execution, it's the same way. So we have this structure called the if-else. If is followed by some sort of a logical statement, can be evaluated to true or to false. Else is not. It's just else with a colon. So the conditional execution here, if you call that function x, it's going to see, is x less than 0? If it's true, say x is -10, you call absolute value and you pass an argument of -10. -10 is indeed less than 0, so that would be evaluated as true. What would get returned is -10 or +10, the absolute value of -10. If you passed +8, this condition is false. And when that condition is false, the statement indented below if is never executed. Instead, you'll get this, whatever's below else. You don't actually need an else. In that case, nothing would happen at all. But if you want something different to be returned, you would include that else statement. So for a +8, you just return +8. That's the absolute value. So here's just an example bit of code we can look at, kind of building on our circle area calculations from before. So really how to package the calculation of circle area into a function and how to print it. We'll go back, get out of my Python 2.7, go to Python 3.4, because that's how I had saved. Where did I put it? Desktop. Got rid of it. Didn't save it well. Here I'm thinking about the script I did for the other slides, circle area. So we did see this example in the prior topic, and you don't need to put that in a function. It's not required, but it could be helpful. When defining functions, it's possible, but it's not probably not practical to write them out in the shell. So instead, we'll open up a new file, save as circle area, a .py, and it's this script that we'll define our functions in. So it's always good to start with a multi-line comment. Next, in class sample of circle area calculation, 8, 24, 20. So in this slide, we import the math module so that we can draw upon kind of an accurate constant of pi. So the first statement to be executed, import math. Then we'll define a function. I'll call it circle underscore area. And what do we need for parameters? What's going to change for different circles is the radius. It's really only the radius that matters. I'm going to call it radius. I can call it anything I want, except those reserved keywords I mentioned. You can call it RAD, you can call it R. I'll call it radius. And then after a colon, I hit return, and I'm automatically indented 1. I do area equals math.pi times radius to the power of 2, 2.0. And now if I chose a different variable name, say R, it would have to be the same within the function, wherever you see it. And then the slide has us returning the value of area. Return area. So if we want to call the function now, so if I just save this script and run it, okay, it ran, but nothing happened. Have to call it circle underscore area, and here we'll pass an argument of 4 meters, 4 feet, what have you. So this time, I'll save it, I'll run it. Still nothing happens. Area is returned, but if I want something printed out, I'll have to put that function call as an argument of the print function. There we go. Now we got an output. And if you want it to be a little bit more clear, you can write add a string, given a radius of 4, circle area will be, and so on. And so that is a workable script right there. We've got a little bit of comments. If we needed more, we could add them using that hash mark sign for an inline comment or single line, and we can call it multiple times. So functions can be defined with any number of parameters. In some of the homework examples, we're using kind of geometry calculations. So, with the rectangle you're looking at, base times height. For a cube, you can look at base, height, length, width, and length, whatever you want to call it, the 3 dimensions of those shapes. Some functions don't have any parameters, but they still need the open-shut parentheses after the function name, just to kind of distinguish them from a variable. You need to pass the correct number of arguments and in the correct order. So pass means enter them when you call the function. So circle area 1.0, we are passing the value of 1.0 as the parameter for that function. You can pass in expressions as arguments, and you can pass function calls as arguments. So that's what we're doing here. This is a function call, circle area 4, and we're passing it as the argument for the print function. Here's an example of that parrot function that takes 2 parameters. And when they're in the parentheses, if you have more than one, you separate them using a comma. It simply prints out the first input and then the second on a different line. This is kind of a facile example of calling another function as the argument for a second function. So print this is basically just a rewrite of the print function. Combine these, returns 2 strings concatenated. And so when you call the combine these functions, passing 2 string arguments to that, and then the output of that expression, which will be a single string, is passed as the argument for print this. When we get into variables, parameters, any kind of variable used in a function, it's important to note that arguments are local variables within the function, and that they won't be accessible outside of the function. So this is kind of can be a little bit tricky, but once you know that, you're going to be able to avoid the tricks. So here we define function parrot using a parameter called val, and then I threw in an extra assigning the value of 5 to a variable named x, and then the output is printing val. So you can call that function, pass a string, and it will get printed. It will get repeated back to you. But even after you call the function in your code, once it's done, the variable val, which is local within the function, has no other meaning. So if you try to do print val again in your code, you're going to get an error if it's not within the structure of the function, so indented in a line subsequent to the function being defined. If it's just at the same level, no indentation, Python interpreter is not going to know what val is. Let's take a look at that. Here we go. If I change that return to print here, and get rid of that, print there, this should still run effectively the same way. There we go. So we got the same output, but where print was called just changed. Now here, if I try to print it again, we'll do print area plus 10. Wait a second as this catches up to me on the virtual desktop. We tried print area times 10. Now if we save and run, we get the original area printed out because this statement is executed. But then When the interpreter tries to execute that statement, it has no idea what area is, because area is a variable that's defined only within the function. And if we try to return that, it's still not recognized here. So in summary, the standard library, kind of what loads whenever you start a new idle session here, Python session, has many built-in functions. The print function, the type function. You can import modules as needed. Some of these are installed, but just not automatically loaded. For example, math. Site packages are collections of modules in one directory. So these are kind of generally just similar to modules, it's just a larger scale. One of the modules, for instance, beyond math, which we'll load, is ArcPy. Once you've loaded a module, you can access functions or constant values within it using the dot operator. So this was when we typed out math.sqrt for the square root function. Functions can call each other, but be clear with the execution flow. And it's a good habit to organize your code by defining new functions. That makes it clear where to vary the input, not within line by line, but as an argument to pass as a parameter. Finally, we'll look at this in-class exercise. This is from the book. I'm going to be using one of the built-in functions from Python called len for length. What does it do? It returns the length of a string. So the value of len, when we pass the string Alan, is 5. So let's call the function using a few different strings to understand how it works. I'll do a new one. And we can call it right within the shell as soon as it loads. So len Nick gives us 4. len Nick space Cuba gives us 9, because that space is a character as well. So what do we have to do? We're going to write a function named writeJustify that takes a string named s as a parameter and prints the string with enough leading spaces so that the last letter of the string is in column 70 of the display. So when we call writeJustify and we pass Alan as the argument, the output should look like this, with a lot of empty spaces followed by whatever argument was input here, such that the n, the last character, is going to be in column 70. So let's see, if we don't know exactly what to write, we do have some kind of clues that we can build on. So the function is going to be named write_justify, and it's going to take a single parameter called s. So in a new script, we can get started on that. Def write_justify, and within our parentheses, the one parameter s. So let's see. Print. Well, we can just start off by printing s, and let's call it write_justify Nick. Save that. RJ, and we'll run it. Oh, there we go. Forgot my parentheses. So when I'm going to resize this window. So in the first draft of the script, it printed out the string, but left justified. I want it to be all the way over here. In fact, I want it to be so that the K is going to be the 70th character. So how do we get it over there? One thing we can do, print s plus, how do we make space? Just include space marks within our quotes. So if I try this, I get a left justified Nick, a few spaces, and then a right justified. So let me see, I'll get rid of that left justified. Run this. And it's getting there. I mean, I can add a lot of spaces in here. Get it to be closer out there. But what happens when I change the value of s? If I change the argument here, it's going to be longer. So I didn't mess with the number of spaces. Instead, the length of the string. And this is how we're going to benefit from the built-in length. So instead of just typing out empty strings here, I can have just a single empty space. And what we'll have to do is multiply that. And we'll call that, call that space. So then we need to define a variable called space. And based on this example, it's going to be some number minus the length of our input s. And the example says we want the last letter in column 70. So if we go 70 minus length of s, and s is going to be Nicholas, then space is going to be 62. And that gives us 62 times a blank space plus s. So I'll save that and run it. And there we go. Maybe I'll have to enlarge that. Oh, it didn't work. But it's over to the right. And let's see, if I change Nicholas back to Nick, there we go. They're right justified. So in this case, when the argument is shorter, s has a length of 4. So the value of space is going to be 70 minus 4, and instead of 62 blank spaces, 66 are going to be printed. And I'll add a long one of nonsense. How does that work out? There we go. And it's still right justified. So they all end on the 70th character of the line because that constant remains so.